Hello everyone and welcome to the first part of this two-part video course introducing high-performance computing or HPC. This course is about supercomputers, what they are and how to use them. It is intended primarily for students at the end of their bachelor's or beginning of their master's degree in a scientific discipline, but also for anyone wanting to find out more about these great computational tools. It is brought to you by the Belgian National Competence Center in High-Performance Computing, EuroCC Belgium. Here is the outline of this course. In the first part, we will introduce you to supercomputers and show you what they are used for. After a brief presentation of our organization, we will explore the evolution of supercomputers and see which one we can access today in Belgium. In the second part, the structure of supercomputers is briefly described, followed by a short explanation of how to interact with them. Finally, we will see how we can benefit from the use of supercomputers using parallel computing and what are the issues of parallelization. So, let's go for the first part. What is HPC? The term high-performance computing refers to the use of supercomputers or clusters to solve complex and heavy computational problems. A cluster is a group of computers, also called compute nodes. They work together in order to perform tasks much faster than a single computer. A single work, or a job, can be distributed across several nodes to significantly increase the speed of a calculation, provided that the program has been adapted for such purposes. HPC has been widely used for decades in academic research, but also more recently by some industries. Supercomputers help to conduct theoretical research in many scientific fields, ranging from pure mathematics to epidemiology, physics, chemistry, biology, and even finance. Many examples can be found on our website at www.enccb.be/stories. Here, I will present a few examples of applications. A field where supercomputing is widely used is computational fluid dynamics or CFD. At CÉCI, a research center based close to Charleroi Airport and host of the largest supercomputer in Wallonia, one of the main research subjects is the aerodynamics of aircraft. Such research may help reduce fuel consumption and thus carbon dioxide emission by civil aircraft. On the other hand, reducing carbon dioxide concentrations can be done by direct capture of the molecule out of a power plant. The vortex unit of the capture system can also be optimized using CFD. Finally, the effect of greenhouse gases, such as CO2, can also be calculated on supercomputers. At the University of Liège, Xavier Vetweis uses the climate model MAR on supercomputers to predict the future climate. Supercomputers are also widely used in material science. The chemical or physical properties of materials can be predicted from quantum calculations. In this first example, the researchers investigated the decomposition of carbon dioxide by gold clusters. A quite large domain of study in theoretical physics is the prediction of the properties of 2D materials, which are materials consisting of a single or few atomic layers of thickness. Their modification can be investigated to obtain desired properties. Many domains of biology are also studied using HPC. As an example, the motion of the protein HID01 can be calculated. The suractivation of this particular protein is linked to resistance to immunotherapy, and the study of its motion can help find a cure for cancer. On a lighter note and another scale, HPC has helped to perform data analysis of the microbial diversity responsible for the fermentation of cocoa beans. It may help chocolate makers to better control the fermentation process and to obtain better chocolate. On the medical side, supercomputers are also used for data analysis. For example, it can help to interpret electroencephalography. In this context, the program SHAMO models the response of the brain to radio waves and runs on supercomputers. There are of course many other examples of the use of supercomputers in all fields of science and engineering. From simulating the behavior of galaxies to optimizing industrial processes or even increasing warehouse productivity. But of course, the use of HPC doesn't stop at pure scientific simulation. It is also used to develop artificial intelligence and machine learning, perform data analysis, and so on. As we have just seen, HPC has been used in many fields, both fundamental and applied, but mainly in academia. Although there are a few examples of industries using HPC, this is a sector that can still gain in performance by adopting HPC on a wider scale. Before going to the next part of the video, let me give you a more detailed introduction to EuroCC and the EuroHPC joint undertaking. EuroHPC Joint Undertaking, or EuroHPC-JU, is a joint initiative between 33 European countries and private partners to develop a world-class supercomputing system in Europe. One of the goals of this joint initiative is to provide access to world-class supercomputers to all participating countries. On the other hand, the EuroCC project was created in order to bring the participating European countries to a common high level in the fields of high-performance computing, high-performance data analysis, and artificial intelligence. To this end, national competence centers have been created to serve as a single point of contact in each country. They bring together the national stakeholders with the aim of boosting the use of HPC. In particular, in the second phase of this project, their goal is to raise industry's awareness of HPC in order to accelerate innovation thanks to its many advantages over experimental testing. In our Belgian National Competence Center, we are then tasked with different missions, including interacting with the industry and the public sector, raising awareness and organizing training for various public, from master students to industrials. Of course, we interact with the other competence centers in Europe and also with the national and regional organizations involved in HPC in Belgium, such as the CÉCI, the VSC, and CNIRO. You can find all this information on our website www.inccb.be. So, where are we today and which supercomputers can we use here in Belgium? Let's start with the timeline of the top performance of supercomputers. Their performance, or speed, is usually measured in flops, which stands for floating point operations per second. However, the number of flops also depends on the precision of the computer. Single precision computers, where numbers are stored on 32 bits, will be faster than double precision computers, where numbers are stored on 64 bits. But with less accuracy in the calculations. Nonetheless, most supercomputers are now in double precision. Here are some of the most important supercomputers during the last 50 years. One of the first major supercomputers is Cray 1, with over 100 units sold by Cray, starting in 1975. It had a power of 160 megaflops. The second version of this supercomputer also became the most powerful supercomputer with 1.9 gigaflops, 10 times more than its predecessor. Note that Deep Blue, the supercomputer that beat Kasparov at chess in 1997, although being around 6 times faster than Cray, was only the 259th fastest supercomputer at that time. Numerous supercomputers continue to break records in the following decades. Frontier was earlier the first exascale supercomputer. Today it is topped by Aurora with 2 exaflops, 10 billion times faster than Cray 1 50 years earlier. Lumi, Europe's fastest supercomputer, founded by the EuroHPC-JU, is not far behind at 428 petaflops. To have a grasp on these numbers, let's compare them to usual computers, such as smartphones or gaming consoles. The first PlayStation, that came out in 1994, was already at 66 megaflops, a little less than Cray 1 that came out 2 decades before. A recent smartphone like the iPhone 13 is around 700 gigaflops, which is 70 times more than Deep Blue. One of the most powerful graphic cards for sale in 2023, the RTX 4090, has more flops than the fastest computer in 2002. And, in double precision, it has the same performance as the Acer Red, the fastest computer in 1991. In general, we observe that the flops are multiplied by 1000 in around 15 years. In Belgium, the two fastest supercomputers are Lucia in Wallonia and Hortense in Flanders, with around 3 petaflops each. The top 500 list is a list updated twice a year that classifies supercomputers by their flops. It was long dominated by the USA, Japan, and China, but the effort of the European Union through EuroHPC brought some European supercomputers into the top 10, with even more to come. In 2023, LUMI is still third in the top 500. This logarithmic graph shows that the increase in performance of the top 1 supercomputer is truly exponential, with a tenfold increase in less than 5 years. Note that the current gaming consoles are as powerful as a supercomputer of the top 500 of 2008, less than 15 years ago. We categorize European supercomputers into 4 tiers. Tier 3 are personal computers that only allow for short-term and low-demand calculations. Tier 2 are local supercomputers, usually located in universities. Every academic researcher in Belgium can have access to these supercomputers. Tier 1 are national or regional supercomputers. Their computing power is around the petaflops, and to access it, you should submit a project. The final stage concerns Tier 0 supercomputers, which are world-class with several hundred petaflops and will soon reach exaflops. These values in flops are given here as an indication and are valid for the early 2020s, but will of course change over time. To access the higher levels of computing, you need to apply to specific calls where you demonstrate the scalability of your program and give your computing needs. In Belgium, almost every university has its own Tier 2 supercomputer. In both regions, the universities have put their resources together to propose a wider range of solutions for the users. In Flanders, the Vlaams Supercomputing Centrum is a partnership between the 5 Flemish universities. It is supported by the research fund Flanders, or FWO. In Wallonia, the partnership between the universities is the Consortium des équipements de calcul intensif, or CÉCI, and is supported by the FNRS and the Walloon region. Both organizations offer free training to their researchers. Moreover, each region has its Tier 1 supercomputer. As already mentioned before, in Wallonia there is Lucia, which was inaugurated in November 2022 and was number 245 in the top 500 fastest supercomputer at that time. It is owned by CÉCI, a private non-profit research center specialized in numerical simulation. The supercomputer is located in Charleroi, next to the central train station. On the other side, Hortense is a Tier 1 supercomputer operated by the VSC and hosted by the Ghent University. These two supercomputers can also be used by SMEs or companies that do not have their own cluster but would like to accelerate their research using the performance of supercomputers. Finally, at the European level, we can have compute time on some Tier 0 supercomputers thanks to the EuroHPC joint undertaking. To access them, we have to submit applications to regular European calls. Soon, an exascale supercomputer, Jupiter, will be available in Germany. These supercomputers are also available to industries that need large-scale computing resources. LUMI is the first European pre-exascale supercomputer. With more than 400 petaflops, it was the third fastest supercomputer in the world and the fastest in Europe in June 2023. It is located in Finland and runs on hydroelectric power, making it one of the most environmentally friendly supercomputers in the world. In Belgium, we have direct access to around 7% of the compute time of LUMI, thanks to our country's funding to the project. Regular trainings are organized in Belgium, and there are a few calls every year to get national compute time. This information can also be found on the LUMI page of the ENCCB website. We are now at the end of the first part of this course, and it's time to wrap things up. In conclusion, you should remember that HPC is at the core of much research right now, and that the European Union is investing a lot in its future development. In Belgium, we have access to many different supercomputers, including Lumi, one of the fastest supercomputers in the world. For the technical description of a supercomputer, have a look at the second part of this course. If you want information about HPC and supercomputers in Belgium, if you need video training or information about future on-site training, you can find them on our website or on the website of the CÉCI and of the VSC. You can also contact us via the contact form of our website. Finally, we would like to thank our funders, the European Union, the FWO and the Walloon regions, and our partners, CNIRO, the VSC and the CÉCI. We would also like to thank you for watching the video, and we hope you will be joining the HPC community very soon.